Hello everyone, very good evening. Once again, welcome back to another session. So welcome to 360DigiTMG. Welcome to Python interview preparation session. So we were discussing certain questions with respect to plots, visualizations, and today also we are continuing the same, right? Okay, if we are trying to do a plot, okay, and Bharat,
Yes, David.
yeah, Bharat, if at all we have to do a plot using a package called as plotly, right? So how we can do that?
Okay, let me just. We can see. I can show you a simple plot using plotly library. Okay, let me share my screen. Are you able to see my screen?
Yes.
Okay. First,
So generally, people think that we have only two visualization libraries we use usually, right? Like most famous matplotlib and also your Seaborn.
yes. So I'll be using plotly.express. There's one particular library, and uh, it is a part of uh, plotly library. So data.iris, we already did this function. Okay, so iris is a pandas data frame. Okay,
The plant with the three species, Setosa, versicolor, virginica, where they are segregating or they are differentiating using the sepal length, sepal width, petal length, and petal width.
px dot okay, let me plot this. I will say scatter plot. X equal to sepal width y equal to sepal length.
Okay, you have your Plotly installed on your Jupyter. That is not required, I think. There's previous. This one, DF.
That is not required.
Run DF.
Which one?
We did not run this cell, na? DF is equal to px dot data dot eres.
No, I did not. Yes.
That is previous code, I think.
Mm-hmm. Okay, let me check this. Okay, there are a few changes that we need to make. Let's quickly make it.
Data frame constructor not.
The parenthesis that we missed. This is the visualization that we get.
Yeah, good thing is that wherever you put your cursor, you have the data also popping up.
Yes.
That is the advantage of plotly generally, which is not possible, I think, right, on matplotlib and cborn.
That is right. So this will really help in, this will help in your presentations for your client especially, and for a better visualization.
So when you will use a histogram, or when you will use a bar chart, whereas you're on mute, huh? Yeah.
Yes, Dipti, yes, I can hear you.
When you will use histogram, you use a bar.
So basically, we use histogram and bar chart for the distribution of a variable. If you want to see the distribution of the variable, you usually go for histograms. And this is especially for the categorical variables. When it comes to bar charts, it is used for your categorical variables. In fact, histograms and bar charts are used for your categorical variables.
Only we say, but I feel that exclusively we can use bar chart only for categorical data. Histogram, yes, we can even use for categorical also, but we can get little insights with respect to even the numeric data. Why? Because according to to add to your statement, bar chart when you apply for numeric data, it will be very clumsy. Very good insights cannot be pulled out according to my analysis. What we have done. Right, so bar charts mostly preferred for categorical, and histograms can be used for both. Preferably, yes, categorical. Okay, so you have a few other plots, for the box plot.
Yes.
What type of plots?
Right. See, we discussed that the bar charts are for your categorical data, and when it comes to box plots, they are used commonly when you have continuous variables. So what happens here is the plot is generally not that informative when you're using it on the discrete data. Okay. So what are the insights? If you talk about the insights, what is that you're getting? What is the information that you're getting from box plot? So you have the minimum maximum score, the lower and upper quartile, the median, the interquartile range, skewness, dispersion, outliers.
Okay. So when you're talking about Blockflow, to add to Bharat's statement, yes, exactly, you're going to get the minimum and the maximum score of the entire data. And the good thing of boxplot is that, it tries to cover entire 100% of the data. And on top of it, it is giving you a glimpse of, how is the distribution of the data. But exclusively, boxplot is used to detect the outliers. It gives outliers on the lower side and the upper side with circles. So people think that if it's one circle, it's not one outlier, bunch of outliers can be there in one circle also. And when we are talking about the minimum and the maximum score, upper quartile, lower quartile, and median, and you have the 50% of the data being covered in the inner quartile range. Generally, uh, what I say, what I see is the final percent gives you minimum value, maximum value, right? And it gives you three quartiles, totally five. Five values have been given in the box plot. Okay. So now, adding to this, Bharat, if at all you're analyzing histogram, and what are some of the features to look for?
Okay, if you're talking about histogram, you have this something called as asymmetric. You can look at if the if the data, if the variables are asymmetric, you can find out, you can analyze outliers. Okay, you can also look at the multi-modality. Okay, and you can also look at the gaps.
Okay.
Okay,
And
the heaping, you have heaping, rounding, right? For example, let's take the data for temperature. Okay, that has the common values due to conversion. What happens in conversion? You have Celsius and Fahrenheit, centigrades and Fahrenheit, right? So the rounding of examples, like you have the weight data, okay, and then you have these multiples, all of these in the multiples of fives, and then you have errors, the impossibilities, etc., etc.
so histogram is something which it also gives you a hint to whether you have skewness or not. It also is telling about the outliers, but every particular plot has its own purpose, primary purpose here. So histogram is mostly people use it to check the skewness on your data. And like Bharat said, that it is asymmetry in your data. Yes, of course, it also tells us about the outliers, because if it is not a normal data, it is having skewness on either left side or the right side. Okay. So Bharat, what is a heat map, Bharat?
So in heat map, what you do, especially in Python, you're cross-examining the multivariate data, and this is represent to a color variation. You have multiple colors, there is a variation, and then there is some kind of a representation.
Okay.
Yes.
Will you show that, Bharat?
Oh, yes, I can. So let me share my screen.
Are you installing Seaborn? You don't have it?
No.
Okay. Where is import? SPLD. Okay, the data you can take is you can generate a 2D 10 by 10 matrix of random numbers.
Okay.
Okay. From 1 to you can use
Okay.
your favorite random dot rand in.
Sure, I can do that. So I will say np dot random. Okay. Equal to 1, comma, I equal to 100. Okay.
You can put size, comma,
Okay.
their own 10 comma.
I is equal to 10, comma, 10. Okay. So now I'll just say print this particular data to be plotted and then I use print data. Now I have this data and then I'll say hm is equal to, okay,
Yeah, sn dot heat map.
import Seaborn I'll do this. Now this is where a heat map will come of the data equal to data.
PLD dot show would be.
And then plt dot show. Execute this. this is the heat map that I was referring to. So it is the multiple colors that you see. It is represented in multiple colors, and you are seeing the multivariant data.
It's like, sorry, it's like displaying all the 100 numbers, right? And the darker the color, it is increasing. And generally we say that heat map is used to find out the correlation between two variables,
Variables.
X and Y. So yesterday we have discussed about the scatter plot, which talks about the two variables. But
Yeah.
as I told you, it was subjective in nature, strength, which is subjective in nature. It can, someone may say it's good relationship, someone might interpret it as bad relation, moderate relation. So to draw some conclusions perfectly without taking anything into subjective, we here take this particular heat map, or if it is not a heat map, if you're doing it something without a plot, it is correlation coefficient, which is calculating the relationship between two variables, and these two variables might have relation or not is checked here. But the good thing of heat map, like correlation matrix, is a matrix what you're getting relationship between one input with all the other inputs, or one output with all the other inputs. The same way heat map also is giving you the relationship between one with all, and with the different colors. The colors indicate the magnitude, or I can say strength. So it is becoming darker, 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 become lighter, lighter, lighter. You have different values popping up, right? Understanding the relationship between the entities. Like this, friends, you have many plots, right? Talking about bouquet package, Pygel, okay, plotly. So there are many such visualization packages which are available, which are giving you beautiful visualizations even using a browser. So one such library here is a Pygel, which is a Python module, and usually that is it is used to build SVG graphs and charts. What is SVG? SVG is nothing but your scalar vector graphics. It is a vector-based graphics in XML format. And the thing is that you can edit it in the editor, right? And Pygel can create graphs with very, very less lines of code. Okay. And we can also have, very, very easy to understand. You can write it easily, and you can also have something called a solid gauge. Right? These are the popular charts which are helping for beautiful dashboards, right? So that you can anticipate different ranges. Like a pie chart we have, right? How you get a pie chart. The same way here also we get certain solid gauge plots. Okay, and also you can have beautiful colors to it. You can add different ranges to it. You can display multiple values to it, right? And the relationship with your what you say is data. So one such is your bouquet also. So bouquet package is also a visualization package here. So that can be also used as a file, and also you can check the output here on your what you say notebook. So the way you are pulling in the lines of code, you are trying to get different views of the output. Okay, so what is that we are trying to do here is, when we are trying to work with this, you can organize your layout, right? You can save your beautiful data creation. You have something called as output notebook. You can also do figure and show. You can also do column data source. Right? You can also create beautiful widgets here, which are helping for better visualization. So certain steps are there for bouquet where you prepare your data, you determine whether your visualization will be rendered or not. You set up the figure, you connect and you draw your data, you organize the layout, then it will be displayed here. So any good visualization should start. Okay, and we want definitely Python libraries, right? That is pandas and numpy. So when we talk about plotly, or when you're talking about Python, different visualizations are possible, and visualizations play a very, very important role, as that we have understood that. And the amount of data we need to work, we need to analyze, we need to explore, and the amount of data is increasing. So it's not just your only matplotlib and your what you say seaborn package here, but it's all that you have many data visualizations. There is a plot called as missing NO, right? Missing NO. That is also a package where it will give you the gaps if you have a missed data, right? So Python allows you the user to create beautiful interactive plots, and it can be turned into SVG charts, printing them, and you can also use them on web pages using Flask and Django. So I think 14 charts categories are there. Right? You can do a histogram, you can do a bar chart, you can do a pie chart, you can do a tree map, you can do gauges, but it is not readily available like your Seaborn package and Matplotlib package. You need to import it. For importing it, you need to install it. Okay, if you have to, you should have Python install, pandas installed, and Pygel also should be installed here. So you can do a bar chart, you can do a plot which is tree map. It's a different ways of projecting your data. You are trying to showcase it so that you should understand certain things, and you have to showcase something. Certain times you want to do only pie chart for your understanding, but on a beautiful dashboard you want to do a donut shape, or or you want a needle shape output to be portrayed on your dashboard. Maybe Matplotlib and Seaborn packages are not giving. So Python is giving this Python library, which is giving us a chance to play with the color of the chart, styles also, right? Different colors can be used here, where you have to pull that Python.style import star. Okay, so these are very few libraries. What I have just explained, like Python and all that. So different visualization libraries are there here for us, which are helping us to understand the data better. So okay, friends, that's it from my side for today. Thank you, Bharat. You all for joining in.
Thank you, Dipti. Thank you, everyone, for joining. Happy learning.